next panel is on floating solar energy, and for that I'd like to ask Francesco Melandri, Aurélien Croc, and Alexander Minger to join me. I think there's one missing. Alexander's going to join us. Bonjour, de nouveau. Hello, hi, sorry for that. We're a bit ahead of schedule. Do you want to have a seat? Because we're ahead of schedule, oh, I'm going to sit here. We have a bit more time even, which is a good thing. So this is about the sunshine. We all love the sunshine, don't we? It's about floating solar. And we're going to start with you, Francesco, if that's all right. You are project manager at Italy's Renewable Energy Association, AERO. And I was going to ask you, could you give us an overview of the current state of floating solar in Europe and the world?
If the map is here.
We have a remote control normally. No? Okay, so there we go. Yes.
It's the other one.
No, the other one. Can we show the other slide, please? There's a second slide with a map, because this is your project, right?
Yeah, this is my
yes,
this is
we
my
can talk
project.
about that later on.
Agnes project.
Can we show the other slide, please? Just 1 second. So, you were going to talk about markets, right?
Yeah. I will try to give an overview about this solution in order.
You have to hold the microphone really close.
I will give an overview of this solution in order to then leave the word to one of the main manufacturers around Europe. So I can start without picture.
We only have one slide, I'm just being told.
Okay,
so
okay.
You have to make do with it.
Okay, so it's not a problem.
Can you hold the microphone really close to your mouth, please?
So we are talking about floating solar system. Floating solar system is growing a lot during the last 3 years. We are around across the Europe. There's like more than 10 prototypes already installed, and there will be other future project with directly integrated to the wind turbine. So. How you can see in the picture, but believe in me, most of the prototypes already installed are located in the North Sea. However, Mediterranean area, thanks to its excellent weather condition, is considered one of the most promiscuous market for floating solar. In fact, there's some information that has to be done regarding this topic, that future projects that will be born in Europe will be integrated with wind farm, and this could create some benefits regarding the cooperation and capex cost between wind and solar.
And so what are the main markets, actually, if you look at the countries? Which countries are ahead of the game?
By the way, I think at the moment Netherlands could be one of the most important market for floating solar, due to the fact most of manufacturers are also already installed the prototype there and have some contract with really important local TSO in order to install their solution also in existing wind farm. So at the moment Netherlands, but I think that France, I think that Belgium should be really close future.
Promising market.
Yeah.
And so you mentioned the Netherlands. Many of these projects are combined projects, right? So we're talking about floating solar with offshore wind projects. Is that right?
Yeah, not yet, to be honest. Right now there's just a prototype that are located in offshore area. However, in the next future, there will be built and installed many commercial scale project inside wind farms. So there's a lot of beneficial in considering hybrid solutions, so wind plus solar. The first is that the complementary between wind and solar. In particular, the solar system produce most during summer instead of wind that produce most during winter. This led to, so the solar solution led to increase production in summer where the wind source is lower. In fact, there's some studies that demonstrate that if you integrate floating solar inside wind farm, the curtailment could be lower than 2%. This means that you have the possibility to install a floating system in a second step, sorry. So when you already have a wind farm. So it's really important for us because there's a lot of wind farm in North Sea. So I think that floating solar could grow really, really fast, consider that topic. In addition, another important topic is energy density. We can assume that considering the same occupied area, the energy density increase around 20%. This means that this solution can create optimization in terms of maritime activities, like between fishing, navigation, and renewable offshore energy. So these are one of the main benefits of the hybrid solution.
I have the feeling that you wanted to react to that.
Yeah, because I'm seeing, as Francesco did, a huge potential with respect to combining offshore wind and offshore solar. I think you highlighted very well the fact that for now it's a nascent technology, but I'd like to emphasize the fact that the markets we see, especially in the Mediterranean and also in the North Sea, are developing quite quickly. In fact, I'd like to highlight the fact that most technology providers have very limited prototype. Okay, you will see in a minute about us, and I'm sure you'll show also something. You will see that we are at the beginning of the technology, and still in the Netherlands, we see the commitment to go for 50 megawatts of commercial project in combination with 2 gigawatts of offshore wind. So I think that it's rather seldom in history than you see such nascent technology being already pushed by authorities towards commercial development. And I really like to highlight that because you can see that in the Netherlands. You can see that also in Italy, where there are already discussions on feed-in tariffs regarding offshore solar. Again, we're a nascent technology, so we are very happy to see that these tariffs are in discussion. They are not high enough for the moment, but they are discussed. We see also some movements in new territories for offshore wind, like Malta, and these guys are also looking at including offshore solar into the offshore wind farm. So I think there's a very strong concept, and it's being tested and developed in Europe. But I also like to highlight the fact that China is moving fast, and as we know, there are some technology there. They did a first try with very light technologies there, as we know, in collocation also. So I'd like to say that the message that we're trying to push is that while we are still at the beginning of something, we see that there is much willingness in different locations in Europe to go and push forward. And what's needed is to push harder, to go for bigger projects, and then we get economies of scale, then we get the possibility to go commercial as quick as possible.
Can I just say, Aurélien, you don't work for Moss Maritime.
I don't work for Moss Maritime, even if I like Moss Maritime, but I'm the CEO of...
You flipped the companies around.
I'm the CEO, sorry, so Aurélien Croc, I'm the CEO of Solar in Blue, and so we're a fellow competitor of Moss Maritime.
Exactly, I just wanted to get
and
that right here.
We're a French startup, right? And as you can hear, we're a French startup.
Exactly. Can we come back to your project? So we saw that. Can we get that one slide again? Because that was Francesco's project in Italy you're working on a combined project of offshore wind energy with floating solar, and I'd like to hear a bit more
Yeah.
about that.
Yeah, we call Agnes Romanga project like an energy hub. This is why this project includes all different technologies. This is our main project right now because successfully passed the environmental impact assessment last year, and is composed by 2 wind farms with a total installed power of 600 megawatt, 100 megawatt of floating solar, one BESS system around 50 megawatt, and a hydrogen plant of around 60 megawatt. So it's quite complex, yeah.
So 100 megawatt would already be quite large, right, for that technology?
Our strategy will be to create like a scalable solution. This means that we will start with 5 megawatt, then we increase to 10 until we reach the goals. The plant will be installed in the north part of the Adriatic Sea, around 12 miles far from the Ravenna coast. And there's a really big advantage compared to the other part of Italy, that there's shallow water. This means that we can consider a fixed bottom solution foundation for wind turbines. And in addition, we are also close to Ravenna port. That is one of the main port in the Adriatic side. This means that we have the possibility, and inside the port there's like one of the main, most important offshore companies. So we are ready to start. We are just waiting for action. To award tariff both for wind and solar.
You're ready to start, but what do you think, what would be a realistic date for this to happen? Realistic year?
Yeah, fortunately this year we received bad news about ministry in terms of time. However, we hope that to complete the plant in the 2030.
In 2030?
30.
Okay. Yeah. And you said you didn't have any feed-in tariff yet in place. How is this going to work?
Yeah, we received the information about tariff. So for wind, for considering our project, it's fine because we are talking about 180 euro per megawatt hour. So it's realistic for a fixed bottom project. However, the most critical part is floating solar, that right now is too low, is around 100 euro per megawatt hour. And for that reason, this solution is not at the moment economically sustainable. For that, with IRO, as I represent today, we are working constantly with the ministry in order to create and define a framework to adopt this solution in Italy.
So do you think there is, economically speaking, if you combine these different technologies, is that maybe the answer? If you say that solar, the floating solar power is not profitable, but for wind it works out, and if you put everything together, then you'd still make money with the project?
No, it's the floating solar yet is not economically sustainable due to the tariff, but we are going to increase with the ministry the tariff, because we believe a lot in this technology. How I described before, also if you integrate the wind and solar, you can decrease the overall capex cost. So at the end, I forgot to mention that if you consider hybrid solution, you can have like 10% more energy production per year. So we think that in this solution will be really realistic especially for our project in our area. So we just need to increase the tariff. Our goal is to obtain the same tariff of the wind. So we are talking about 180. That is reasonable for a new technology like floating solar.
Okay. You haven't chosen a technology yet, have you? For the floating solar?
Not yet. We are still evaluating technology, also because all of them are in prototype stage. However, I said we believe in this technology, so we are working hand in hand with companies. Also, because our goal is to create a technology that could be scalable, mature, and sustainable for the Italian market.
Right. So it just so happens that we've got two technology providers with us. Maybe, you know, one of them is the right one. Can we talk to you, Aurélien Croc, and get to know a bit more about how your technology works? I think you brought a video.
Yes,
Is that right?
Yeah. So
and you work for Solar in Blue.
Exactly, and I do work for Solar in Blue, yes. So I don't know if we can show the video. That would be great indeed. But just while the video loads, so basically Solar in Blue, we're a French company. We're based in Montpellier and Sète, so that's southern France.
Okay.
Thank you. That's southern France, and we have two floaters that you can see here. So this is our demonstrator. And the key feature of our technology is the ability to climb up the wave and then going down. Okay, so in technical terms, we are over buoyant, okay, meaning that we float more than our own weight, and then we can really ride the waves up and down. Okay, this means that we can elevate the panels by very little. Okay, so this is roughly 3 meters, while handling waves with our latest design up to 14 meters. Okay, so we have some kind of leverage. Okay, we go up the wave and then go down, meaning that we don't need to elevate the panels too much. Also, one of the key features in this demonstrator is that, as you can tell, we have two floaters, and these two are connected using a patented link. And we are very proud of this, because this is what guarantees the scalability of the product, okay? When you connect two, then you could connect three, then you could connect four, and then go bigger. And as you said, the challenge is to scale offshore solar. So this is really what we are demonstrating right now. The idea is that in Sète we have very challenging conditions, meaning that last year we handled waves of 9 meters, okay? And this year it was a bit smaller, it was just 8 meters, but we are very happy with the results, and we believe that we hold the best track record in real conditions for sustaining waves. And moreover, these two have been afloat since almost 18 months now. So we also have the feedback on the energy production. And we're happy to use an elevated technology that enables to use bifacial panels, okay, which can get the solar irradiance from the top, but also the reflected irradiance on the sea surface from below. Meaning that overall, we get to have more production than what we get onshore. And it combines very well, as you said, with other energies. And what we anticipate is be able to add this technology into an offshore wind park. And what we are currently looking at is basically the wind production from floating farms in the Mediterranean, comparing that to our production and showing that there is indeed the possibility to do multi-energy hub, what Agnes does very well, associating wind, solar, and possibly hydrogen, whatever, onshore. So yeah, that's what we do, where we are now. And we, thanks to these two demonstrators, of course, we gained great insights from the technical side, but it also helped go to the next phase, which is scaling up to 1 megawatt, and that's the project Megaset. And I can talk about it now or later, as you like.
Yes, absolutely. I was just going to ask you regarding your device that was put into the water in 2023. Can you talk a bit more about what you learned with that installation? Is there also something that you will do differently, maybe?
Sure. So we definitely learned a lot. Basically, what we learned is that simplicity is key in terms of onshore assembly. So if we can bring back picture, you could see that we have a truss structure which requires a lot of assembly. We are currently in the process of simplifying that and having, a design that's far simpler in terms of onshore assembly to produce So that's the vision, but I think you explained it very well. But anyway, so the structure to be assembled far quicker onshore, because when you want to go for this kind of project, you have to produce a lot of floating solar units. Okay, so this we would do differently, like to try to streamline the process for construction. Also, what we understood, and that's the reason for for having this visual, is that what can be actually built inside a port is basically the maximum size of it is basically the size of a cargo. Okay, and that's why you previously you had the shape of a cargo. Okay, that's because that is the maximum size that you can tow out from the port. Okay, so also changing a bit the vision. From at the start, we would like do huge squares, but in fact we understood that it's not really doable to do assembly offshore. It's better to do everything in the port, and then you have to reduce to the size of a cargo. Voilà. And also, I think like everyone here, we also learned that everybody hates geotechnics and that it never was as expected. And we did pay a tribute to that also. So as all of you, we also had problems with the seabed not being what we expected and having to redo the anchoring. But yeah, I think that's an experience that a lot of people share in this room.
So what does that mean? There were
basically that you expect that you have sand for a few meters and that you can go with some specific, for example, helical anchors, and when you do it and you need to do several of them, let's say 4, in fact you have 3 that works and 1 that doesn't, and then you have to go for a fallback solution. That's not exactly what was forecasted, but for a small project and a small company like us, it of course has a lot of impact on the project, and yeah.
And what we're seeing now, what we were seeing beforehand, that's the next future,
step.
Right?
Well, exactly. That's the next step. So that's for 2026, and this is Megaset. Okay, so this will be the replacement of Sunset. Voilà. So this is 1 megawatt, and the key difference.
This one, not the other one.
Yes, this one is 1 megawatt, okay. Exactly. And the key difference is that, of course, you can tell that you have a fully consistent farm. Okay, just not two floaters. Plus, you also get the floating transformer unit, which is a marine container that you guys can see on the upper side, which hosts both the HV transformer, the inverters, and the dynamic cable to export the electricity. Because I didn't mention it, but with the previous version, of course, it was not connected. There was no economical sense to spend on the cable for just 2 floaters. But there, it does make an economical sense, and it's also part of the de-risking to show that the dynamic cables, which are currently mostly used for floating offshore wind, can also work in the specific context of our technology, which is different, again, because we ride the waves and then we tend to move a bit more than floating offshore wind typically.
So if I understand that right, what we're seeing now, we saw the video of the 2 floaters moving. That would also be moving.
Exactly. This farm would also be moving. That's the key idea. Again, we have to hold very difficult conditions. At Agnes site, I think it's something like around 11 meters or something for the 50 area.
Yeah, 11 meters.
Well, 11 meters. So that's 11 meters. So one way to handle that would be to put, it's 11 meters, okay, so I do an 11-meter high structure and it works. So of course it works, but it's too expensive and we need to be competitive. We need to be at parity, as you said, we need to be at parity with offshore wind. And to achieve that, then you can't spend too much on capex and you have to get some leverage. And this leverage is thanks to the over-buoyancy of the platform.
Okay, all right. Can I ask you to talk a bit about your technology?
Yes.
So you are Alexander Minge Torgersen, you're VP Engineering at Norway-based Moss Maritime.
Yes,
Maritime,
that's correct.
a Saipem subsidiary.
Yes, 100%. Actually. Yeah.
Can you hold the microphone really close to your mouth?
Close? Can you hear me now?
Perfect.
Good. I think it's a picture of our technology as well, but I can say that we share lots of the same philosophy that Solar in Blue, my colleague here, is mentioning. I think we have the same philosophy that we don't want to work towards the sea, but we work together with the sea. And I think a nice picture of how it behaves is if you could look at a carpet on the sea, it flows like a carpet on the sea. And as mentioned here, that allows us to take down the air gap. And you can see lots of the same philosophies as with Solar in Blue. But we have this low air gap, as you can see. We unfortunately have only one on this picture to show you, which is our prototype in Norway. But of course, the idea is to, or the vision is to expand this into several of these. And if you are to build megawatt parks, you need several hundreds of these islands or these small floaters in order to build up. But it's highly scalable, and I think it's very, very comparable to what you already have seen. And we have worked on this since 2017. And I think that we have been through different testing of it. And what you see here is the first generation that we had. Mm-hmm. And you asked if we have learned something, and obviously we have learned a lot of this. What you see here is basically, I think, is the easy part. The difficult part is when you are looking into the supply chain, are supposed to build 100 of these. And you have to do it within a certain time frame, and you also have to take it out offshore. So these are the two main things that we have been working on after we have kind of developed this, because I think we are confident that we have developed something that will work, but we need to demonstrate it through a pilot, which is more than what you see on this picture. But these are kind of the learnings here, that we need to work on the supply chain, how to do the assembly efficiently, and how to efficiently install it. And this is a new thing, because personally I'm coming from the oil and gas industry, and I tend to hit it with the big guns, basically. But you have to think otherwise here. You have to start in the more lower end. So yeah, I think beyond that, there's not much to say. We have tested. I think one important thing to mention is on all demonstration and pilot projects, you need to have a lot of instrumentation, and that has been challenging actually. They seem to fail and not work as you want all the time. So. Yeah.
And can we imagine it? We just saw a video from Aurélien.
Yeah.
Would it be in a similar way? Would they be, also going up and down,
yes,
connected to each other?
Yeah, it's same principle. I think it's the same principle for all the offshore floating solar technologies out there. There are some different philosophies when it comes to how flexible they should be, but they all kind of tend to work with the sea, more or less. Yeah.
I was just wondering, I think the solar panels also have to be a bit specific. You can't just, because there are obviously lots of solar panels available, but they need to be specific.
That is the big challenge. There is no, some PV manufacturers are looking into this, but they are not a developed market yet. So you tend to have PV panels that are made for calm sea locations, but putting them in offshore conditions are supposed to be there for 25 years. That has not been proven yet. So that is something that needs to also come with the industry and the supply chain. So, yeah.
Right. Do you want to react to that?
I'd just like to emphasize the fact that in China we see the first fixed bottom, offshore solar for very shallow waters, like 3 to 4 meters, something like that. And they do gigawatts of these.
Gigawatts.
Yes. So many manufacturers in China have already taken the step to offer warranties for panels that are really offshore. So it's fixed bottom, but it's really offshore. It's 10 to 20 kilometers, something like that, offshore. And the panels already hold a warranty and everything. So there are already product lines for fixed bottom, but I think that we both share the view that the technology we are developing enables for the panels to live their life as if it was fixed bottom, because they don't take any impact from breaking wave, right? Because we are always riding the wave, so they never get any impact. So in fact, I think the key objective we share is to offer for the solar panels the same experience as the one they get on these, not that much known, I think very little people know about it, but these gigawatt projects in China already offshore.
But these gigawatts projects, if they're fixed bottom?
Yes, fixed bottom, yes.
Do they not need, sorry, maybe you don't know that, but do they not need specific solar panels then? Because
I'm giving my own opinion here, but the thing is that it's always better if you're a PV module manufacturer to have a new product line, which of course is more expensive, and where you warranty against offshore. But in fact, when you really look at the technical characteristics of these solar panels, in fact, very slight, very slight differences to mainstream solar panels. And this is why I think both you and us deployed bifacial panels, anodized aluminum frame, which are mainstream solar panels, and just the exact same that you would put on shore. Voilà. And it works.
Okay.
I think that there are other testing projects as well, as you say. So I think we are on the right way, I would say, to achieve it. So I think it is progressing, but there is still a gap that needs to be covered. But I think in particular within this, and also when it comes to soiling and loss of production due to birds drop and so forth, is also part of what are being investigated now. So things are happening, as we say, and with the progress in China, I think we are very quickly there, actually. Maybe already. So, yeah.
And Alexander, what do you think? What will be the main markets for floating solar across the world? Can you hold the microphone really close?
Yes.
The main markets for
what the
floating.
future markets will be?
Yes.
Yeah, that's a good question, obviously. And if I knew that, I think I would be relaxed in a way. But I think I think at least we are working out of, call it 3 different trends. And if you're looking at the gigawatt projects, standalone projects connected to the grid, I think we are somewhat into the future on that. I think we need this stepwise development with good pilot projects in order to demonstrate that we manage 1 megawatt, 10 megawatt, 50 megawatt, and then maybe gigawatt. So that is kind of the dream, not necessarily something you should focus on now, at least we are not doing that. Then you have the next step maybe, which is the hybrid, which we have talked a lot about. I think that is the next commercial sized projects. And of course we are really linked to wind and how wind is progressing in a way, at least for the new projects. But the beauty of this technology is that you can of course use it in existing parks as well. But we have the same challenge to convince the developers and the clients of us that this is robust solutions and it will work for 25 years, problem-free. And this is a work we have to do, because I don't think we have managed to convince yet. But we need to do these projects, the demos, in order to come there, probably several. Then I think we are helping each other in the way we are working now, in order to show that there is actually people working on it, and I think we can manage it. And maybe in the very short term, at least from, again, my personal view, is that we have the smaller from kilowatts projects, which can serve as a power unit to smaller consumers. Within aquaculture, for example, up to maybe small islands, as is maybe of 5 to 10 megawatt demand in a way. And I think that is kind of the first runner for this technology. If you can do that, I think we have a credibility to move to the next one. And the beauty of these smaller projects is that you are lower risk. The capex investment is not that big, and you can probably also push some of the guarantees on the technology developers, because the warranties is the key issue here. I think no one wants to take the warranty for the larger projects because we are not convinced. Yeah.
Can I ask just the two of you, if you're looking at the Italian market at all? Are you interested in Francesco's project?
Of course, being Italian in a broader sense, yes, we are looking at Italy as a very nice place to have floating solar, obviously, yeah.
All right.
So not being specific about that, but of course it's a nice place, and I think, as already explained, there is good movements on getting something done in Italy, and being Saipem and Italian, that of course is. Yeah.
Do you agree with that?
Yeah, sure. and just for the go-to-market, I think the strategy, you summarized it. It's basically you have small projects in places where the electricity is expensive. Okay, that's namely islands. So there you can go, as you said, on your own. Okay, no need to go for big offshore wind developers and everything. You can go there yourself, and you can have a business case ready right away. You can take, in a sense, the risk on the warranty and everything. But I think that this go-to-market is something that we have to follow, and we are indeed working on that. But I strongly believe that we also need incentives from the authorities to go with the multi-energy project developers like you, and there are others, who are already, even if this is again a nascent technology, already willing to subscribe to that vision and develop projects where we are not looking just at 100 kilowatts, and how to support them with tariffs that are at least at the same level as the one that you would get for floating offshore wind. And with that cost structure, we can have a farm combining the two energies that has an economical equilibrium. Yes, there's a bit of risk, but I think that we are all, making, very nice demonstrators and prototypes, and we need some help to scale up fast.
So probably, hopefully, sunny days ahead.
Yes, exactly. In the Mediterranean.
Yes. Thank you very much, Francesco Melandri, Aurélien Croc, and Alexander Minge Torgersen for taking part. Thank you. And thank you for listening.
Yes.